you'll find some new language in Article 705 related to that as well.
All right, so we're going to get this show started. We're going to be talking NEC 2020 Code Changes Day 4. And, all right, so we're going to be we're talking 2020 Code Changes. Today's agenda. Hopefully everybody can hear me. I got everything turned on. Yep. All right. Again, all of your from a WebEx perspective, all of your microphones have been muted as usual, I believe. Please double check. Make sure that you have that those muted. Make sure your things are muted. I'll try to do whack-a-mole as we go through, but you guys have been getting very good at that. I very much appreciate it. Again, I reiterate, I am not speaking on behalf of any code making panel, NFPA, or any other organization. Anything you hear is of my opinion, and please please put your opinions in on the chats. That's how we all learn. Use the chat on WebEx, and please use the chat on YouTube as well. So the more interaction we get there, the better off we are. So I really appreciate everybody's contribution and keeping us all honest and up to date with the latest information. And this is our agenda today. I'm going to go over load calculations, short circuit current ratings, which is really on the SCCR. It's more about marking of available fault current. There are some expanded requirements in that area. Selective coordination, disconnects, ampacity, and some the stuff at the bottom are pretty much, there's some miscellaneous items I need to clean up that we've mentioned throughout these 4 days. You've taken some quiz items on these items, and we're going to close the gap there. And I must say, for anybody who didn't receive a certificate yet, didn't get the link or whatnot, please send me an email. I'm addressing those. Thank you for your patience on that. And we are going to go to the quiz. Awesome. Well, I can tell you that I was surprised at some of these results. Surprised in a good way in some cases, not such a good way in other cases, because I know that you guys and gals on the phone and on the phone, here I am, on the web have know better in some of these areas. So I need to work on you guys. Here we go. The short circuit current rating of a panel board is determined by the manufacturer and not the installer. 124 say true, 30 say false, and 7 are not sure. Well, I'm going to give you my perspective on this one. When it comes to a panel board, yes, the manufacturer will put some information on the inside of the door, and we test, and we can say that we know that the short circuit current rating of what the short circuit current rating capabilities are of that panel board. But the short circuit current rating of the assembled unit when it's installed is determined by the installer and not the manufacturer. We're going to talk about that in detail. We're going to review some of the labels on the equipment. So depending upon how you take this one, I'm sure that a lot of people, when I say panel board, they're probably picturing an enclosed panel board with breakers installed. But some of that 148 may be thinking of that panel board just inside the box without any overcurrent devices, etc. So in any case, we're going to take a look at this one. I would vote for false if it was me. But again, it's all in perspective on where your head was at when you hit that true button. And we will go through so you completely understand the perspective of the short circuit current rating of a panel board and switchboard, especially those two, because they're really, we publish, as a manufacturer, we publish the recipe, but it's up to the installer as to determine the short circuit current rating as it is installed. We will get into that one. So I'm sure you're probably scratching your head. Everybody's mad at me because of the question. but that's okay. We'll get into it. This one really upsets me because I know we went through this. Circuit breaker's short circuit current rating is dependent upon the voltage it is applied at. I know it's a poorly written sentence. I shouldn't end it in the word at, but circuit breakers do not have a short circuit current rating. Circuit breakers have an interrupting rating. So the answer to this one should have been false. U46, I love you. U149s, all right. It's circuit breakers have an interrupting rating. Fuses have an interrupting rating. We're going to talk a little bit more about that in this program, but I know I covered it in my fault current class not last Monday. Geez, that would be 2 Mondays ago, 2 weeks ago. It's hard to believe that I've been cooped up in this basement for this long and I haven't gone crazy. This might be a form of crazy. I don't know. But in any case, 58, I'm loving you guys and gals. We will talk a little bit more about this, but circuit breakers have an interrupting rating, not a short circuit current rating. All right, so this one here, whenever we talk selective coordination, and I had my class 2 weeks ago, just about. I always show this as a precursor to any of my discussions. I met with some consultants, and I've had some people say, "Look, Tom, you're going to come here and talk to us about selective coordination. This is what we do for a living. Just tell me how you can make my life easier and help us get more accurate with these. Skip the what is selective coordination." And before I honor that, I always give this quiz, because if they get it wrong, then I go into the details and I explain to them what selective coordination is. If they get it right, I skip this and I go straight to what are the solutions that will help make their lives easier. Now, 122 of you said yes, they selectively coordinate. 27 said no, and 61 said maybe. I'll tell you where I'm putting all of my chips, and I would feel very comfortable in the maybe column. Those 61 were probably all in my selective coordination class a couple weeks ago. The 122 that said yes, you're probably sitting there going that Tom is crazy, he's nuts, because there is clear separation of curves all the way down to 0.01 seconds, and there is no way that downstream red breaker is going to go before the upstream blue breaker. But I would tell you that what you are missing is what the available fault current is that they are going to have to interrupt and stop the flow of. Because if the fault current was, say in this case, 10,000 amps, I can guarantee that both of those overcurrent devices are going to open if they both see 10,000 amps. In fact, based upon our testing and our tables, our selective coordination tables, I know for a fact that they will selectively coordinate up to 1,500 amps. Anything beyond 1,500 amps, and they will both open. So, the right answer to this is maybe, and the reason is because I did not tell you what the fault current was that both of these devices would see. You can't determine selective coordination to any value. I don't care if you don't feel that three-phase bolted fault current is a realistic number to selectively coordinate to. You have to pick some other value of fault current. I used to fall back on the arcing current. IEEE Red Book would publish a certain percentage of the bolted fault current. I'd fall back and say that I selectively coordinate for the most common fault current, which is the arcing ground fault, which IEEE would typically publish a percentage value. So, but in any case, you really need to know fault current. I agree. I picked true, but I really considered the maybe. Absolutely, Keith. It is maybe. And the key thing, so I remember I was in California and I was at a consulting engineering firm, and I went in and they gave me that exact same language. They said, "Look, Tom, I don't need to know what selective coordination is. That is all we do. We do coordination studies, arc flash studies. Let me know how you do business, how you can help me do business easier. And I put these two curves up, and I said, I'll make you a deal. If you can tell me if these selectively coordinate, and I will skip this. And if you miss this question, I'm going to get into the details. And the youngest guy there, he raised his hand. He says, I'm confused. I says, why? He goes, well, you didn't tell me what the fault current was. And I said, thank you very much. You guys passed. And then we moved into how we can make their life easier. So that is this is commonly missed. Zone selective interlocking is a way to achieve a selectively coordinated system. At one time in my life, I know I am going to give a class, ask this question, and everybody's going to get it right, because I am going to have hit every engineer and contractor out there, and manufacturer, because I have heard some manufacturers say this wrong. Zone selective interlocking is not a way to achieve selectively coordinated system. Zone selective interlocking is there for incident energy reduction. And I know why people get this messed up. It is because of how we teach it. And how we teach it is that we'll always say that these two breakers are connected together, and when a fault occurs downstream, the downstream breaker says, I got it to the upstream breaker, and he holds those contacts closed while the downstream breaker does its job. And it sounds good. And to a point, it's right. But what they miss is that if you don't program the set points, when that fault occurs downstream of both breakers that are, and it's outside of the zone selectively interlocked zone of protection, they go by their programmed settings. There's no magical thing that it's going to make the upstream breaker hold its contacts closed and ignore its settings. If you didn't set them correctly, they will open. If you have an overlap in the overload region, they will trip. The upstream could go before the downstream on overload. If you have a misprogrammed in the short time delay region, the upstream breaker could trip before the downstream breaker on short time delay. And if the fault current is greater than the instantaneous pickup of both of those devices, they could both open. Absolutely. Zone selective interlocking or not. You have to make sure you understand ZSI is there to act when a fault occurs in between those devices. And only that is the only time and the only benefit you get from a zone selective interlocking, which is a huge benefit to preserve the safety of the equipment. We've sold that for years. We never sold it to meet selective coordination requirements. We sold it to provide equipment protection and reduce the arc flash and incident energy should an event occur on the bus inside of that equipment. So this is split. One of these days, everybody's going to be in the false column, and I'm going to feel very good about myself, and I'll never have to give this question again. I'm looking forward to that day. I don't know how I get multiple choice, and you know what? Everybody is just follows suit. You guys pick a question. I don't know how I missed that one. The service overcurrent protected device and the feeder overcurrent protected device supplying power to an Article 700 transfer switch must selectively coordinate with each other. We got 115 trues, 54 falses, and 23 I am cluelesses. If you're going by the NEC, I didn't say per the NEC. I should have, because some of those 119 may be. This is a good design goal. It's not necessarily a code requirement. I'm going to explain this, and some changes around selective coordination in the 2020 version clarified this. But the elevator speech is those two devices that are on the normal side of the transfer switch are not in the life safety Article 700 system. They're not covered by Article 700, so they do not have to selectively coordinate with each other. So that's the elevator speech per the NEC. We're going to dig into the details and the new informational note that was added to help you understand that. But I would say it is a very good design goal, and the reason I say it's a good design goal is because anytime we can eliminate the necessity of a transfer switch having to perform that transfer, we're increasing the reliability of the system. If I can avoid having my emergency system come on because I cleared a fault correctly on the normal side, then I have increased the reliability of my power distribution system, because you never know. The generator may not start. The transfer switch may not transfer. Avoiding that transfer increases reliability in the system. So on that one there, I would say the 66 of you, good job. Thank you very much. You can stand up, pat yourself on the back. So when calculating lighting loads per NEC 2020, you must remember to add 1.25 to account for continuous loads. Now, if I would have said NEC 2017, I would probably have said, yes, that would be a true. But the 2020 code made a recent change, and that is one of the first things we're going to hit out of the chute, that we built in the 1.25 into the table 220.12. So stay tuned. Those 69 went to the code book probably and found that answer. And those 10 not sures, thank you for being honest. And those 70 are now, I mean, they heard the answer and they're jumping on that bandwagon. That's just the horse races. So in any case, the right answer to this one is false. Multi-case circuit breakers are required to be listed in the NEC. Look at that split, 96-96 and 12 not sures. The only place in the National Electrical Code for a multi-case circuit breaker, there is none. What am I saying, the only case? The only case for a circuit breaker to be listed is when you recondition it based upon our discussions in our last meeting. And the only breakers that you're permitted to recondition are power circuit breakers. So multi-case circuit breakers, unfortunately or fortunately, depending on which way you look at it, they're not required to be listed in the National Electrical Code. Now, I know there are some jurisdictions that will require this, and I can say that as far as the authority having jurisdiction, they will be reviewing, anytime you have a product that's installed, the inspector, the electrical inspector, the authority having jurisdiction will have to approve that. We make their life easier by putting that little sticker on there for the listing mark. If they can look and see that it was evaluated and it was listed to a third-party standard, that makes their life a lot easier. If it's not listed to a third-party standard, they've got to really look at the instructions, look and make the considerations and figure out how they're going to feel comfortable making that call that it is okay for that installation. So they will normally look for that listing mark. And if it's not there, and if you put a multi-case circuit breaker out and it didn't have a listing mark on it, it would probably send a red flag to the inspector. They would look for in a field evaluation, they would ask a lot of questions. So that listing mark takes a lot off their shoulder. But in the National Electrical Code, there's nothing that says it has to be listed. To determine proper short circuit current rating, first calculate the asymmetrical fault current and then ensure SCCR is greater than that value. 117 said false, and I am with that 117. And the reason is because we calculate the symmetrical fault current. We don't calculate the asymmetrical fault current. All of the equipment ratings, you will simply calculate a symmetrical fault current and do the comparison, because we take into consideration the worst case X to R ratio, and we'll do an analysis. Now, your X to R ratio has to be greater than, say, 6.6, which means it's a highly inductive source, and which could be very close to a transformer where you have a lot of inductance and not as much resistance. But the moment you start adding conductors, that brings the X to R ratio down to a much more reasonable, realistic number, less than 6.6. So the key number you're looking for from an X to R ratio is 6.6. Anything greater, and I would look at the ratings, talk to the manufacturer about proper application, and possibly derating of the equipment. But in any case, the right answer to this one is false. And can I get a hug? Those 16 sure can. Virtual hug on your way. And that was it. So that was good. I appreciate everybody taking that. We had a lot of good respondents. A little bit disappointing, because a lot of it's material that I went over. But you know what? That's why we do these things. That's why we do the quizzes, because hopefully it shows you that you're not alone in your perspective. But that's all I have to say about that. Let's move on into the program. The first section we're going to cover is 220.12. There were some big changes in 220.12. There was a task group associated with this. And if you look at 220, I'm just opening my code book, as I know everybody out there is opening their code book to 220.12. If you look, we changed the title from the 17 cycle to the 20 cycle, and we removed the dwelling unit. Remember, in this table, I'm gonna look at my 2020, my 2017 code book. That way, I'm gonna open both of those so I can do a little bit of a comparison for all of you guys and gals. So 220.12 used to say general lighting loads by occupancy, and in there, there was the in any of the preceding occupancies except one family dwellings and individual dwelling units of two family and multifamily dwellings, they had that one in there, and also up at the top they had dwelling units, which was 3 VA per square foot. So what we did was we removed the 220.12 references to dwelling units, and then we modified J. So in the 17 code there was a J, dwelling occupancies, and it talks about in 1 and 2 family dwelling, multifamily dwellings, and guest rooms or guest suites, and it gave you some of the language, or it give you the language on how to calculate your lighting loads. But remember, in the dwelling units, we lump lighting and receptacle loads into the same calculation, and that was why we had to move it out of the table 220.12, because of the changes that we did in 220.12 really focused around ASHRAE and the requirements. The argument that was made was that we're designing buildings to meet these new ASHRAE requirements, which have limitations in watts per square foot that you're allowed to have in a facility to meet those requirements. Now, a key thing that I said there was watts per square foot. What we learned in our task group, in fact, I had one of the members call me Mr. VA, because I kept reminding everybody that when we size equipment, we don't use watts per square foot. But ASHRAE and those energy code guys love to use watts per square foot. And the reason is because we always relate that to our energy bills. We pay for watts. We don't necessarily pay for VA, unless you're in those large commercials where you get penalized for power factor. And that gets you your VA bills. But in any case, the focus was on the fact that a lot of our lighting is moving to LEDs and the lower energy profiles, which has to impact our load calculations in some manner. So if you'll notice that we looked at ASHRAE 90.1-2016, and you might say, why did you reference 90.1 2016? Because we don't have ASHRAE's on a much later version than that. The issue that we came across was similar to what we find with the National Electrical Code. The ASHRAE documents, the ASHRAE requirements are not accepted and adopted across the country as soon as they come out. So there are states that are on older versions of these ASHRAE requirements, and there are states that are on newer versions of these ASHRAE requirements. And I would say, I could argue that there are states that aren't on any version of these ASHRAE requirements. But suffice it to say, most of our design engineers are designing structures and commercial buildings to meet some level of these ASHRAE requirements. We didn't want to get very aggressive with the low VA per square foot, well, watts per square foot, but you have to convert that to VA. We'll have a discussion about that later. So we focused in on the 2016 because we felt comfortable that the adoption of at least the 2016 was probably something that that we could live with regard to lowering that VA per square foot for some of these loads, but not get to a point where we lowered this, we drained the water in the swamp so low that we're going to start seeing the rocks, if you catch my drift there. Because remember our equipment. I mean, if you think about it, we've been doing load calculations for quite some time, and the concern that was raised was that we do these load calculations, and yes, do we have transformers that are probably bigger than what they need to be? Sure. We have conductors that are probably bigger than what they need to be. Yes, we probably do. But as we start lowering the rating, closing the gap between what's actually being used and what the rating is, there's probably going to be more heat generated in all of this equipment, and how much of the capacity that you're leveraging, what that impact is on the longevity of the equipment is really unknown, because we probably have been sizing these things differently. We've been in this practice of a larger margin for quite some time, and that usually covers a lot of mistakes, right? When you look at some of like the NEMA starter versus the IEC starters, they'll say, man, those IEC devices are so much smaller. They are, but you get a lot of forgiveness in a NEMA starter. You don't get any forgiveness in those IEC for, types of solutions. And when you make a mistake, you let the smoke out, and that's not a good thing. And then they have the longevity thing. So we just did not want to lower that number too low, but we wanted to recognize the fact that we are moving into a world of higher efficiency types of solutions down at the end use, down on the ends of those branch circuits. Specifically, lighting was low-hanging fruit. So in any case, we focused in on the 2016 version. And again, the VA per square foot for a lot of these installations did come down. I see a question, is it 220.12J or 220.14J? That's a good question. I believe it's 14. I may have said 12. Yeah, 220.14 is other loads, other occupancy. 220.14J. I'm sorry about that. I was in the 212 zone, but it's 220.14J. Thanks, Bill. All right, so here's what, yeah, there it is. It's right on the screen right now. I had to look at my code book, and I should have just looked at my slide. 220.14J, we changed this to be dwelling units instead of occupancies. And we instead of saying 33 VA, we just spelt it out, volt amperes. Wanted to add a few more pages to the code book. It was getting too thin there for a while, so we had to bulk it up a little bit. And we made some minor changes there. And then you'll notice we have the lighting outlet specified in 210.70. We didn't specifically call out A and B. So that was some minor changes there. But so we didn't really change anything in the on the dwelling unit side. We just relocated, we pulled things out of the table and put them over to 220.14J. So the 3 VA per square foot, volt amperes per square foot is put into J, and I believe the 17 cycle. Yeah, the 17 cycle simply referenced 220.12, if I'm not mistaken. I'm just looking to see, make sure. Yeah. So it says are included in the general lighting load calculations of 220.12. So we separated the 220.14J from 220.12, kept 220.12, especially that table for non-dwelling units. So if you look at 220.12, we did a couple things. So number one, we adjusted the VA per square foot, but what we recognized was that the occupancy types that are in 220.12 didn't correlate with what ASHRAE and the energy codes were using. They were correlated with each other, but what we called banks There was nothing in ASHRAE, for example, that said that a bank is an occupancy type. And when you looked at all the data that they would be using for watts per square foot determinations, it was critical that we line up the terminology in 220.12 with the terminology in ASHRAE. So you're going to see that in some of the cases we did, if you're familiar with, if you're a bank guy and you do banks all day and you go to the 220 and 12 and you don't see banks anymore, you have to know that now they're considered an office type occupancy. I mean, so we sort of went through that logic saying, well, what would be different in a bank that you wouldn't see in a general office? I mean, so other than a big old safe with probably a big lock on it, motor driven probably, but it's pretty much the same, especially from a lighting perspective. Hotels and motels hasn't changed, but the VA per square foot went from 2 to 1.7. So that's an example where your VA per square foot went down, which will probably lead to smaller feeders and services. And then what was previously referred to as garages is now commercial storage, is now to be considered as parking garage. And again, that went from 0.5 to 0.3. So you'll notice in the bottom of the table, in the footnotes to that table, we basically took all of what was in 220.12 in the past, any of those occupancy types that changed, we gave you a footnote to tell you, here's what here's what we used to call it, and here's what we call it today. We went back and forth with, do we put it in the actual table or do we put it as a footnote? And, we settled on a footnote. I think it made the table a lot cleaner, but you will probably scratch your head if you were looking for your specific lodge room and say, well, I don't see lodge rooms in here anymore. You got to know that it's now hotels and motels. And banks are now office type occupancies. And clubs are considered restaurants. Barbershops and beauty parlors are now retail occupancies. So that's sort of, and stores are retail occupancies. So we lumped some of these together and hopefully made it a little bit easier. All right. Let's see here. Let's move on. Now, 220.12, again, the new table helps the healthcare industry, but adding a new occupancy type of healthcare clinic, so what we did was we created a healthcare clinic, and which wasn't there before, and that's at 1.6 VA per square foot. If you looked at hospitals went from 2 VA per square foot down to 1.6. So we lowered the VA per square foot for a hospital. Now, we did that. We made a change, I think, in the positive for hospitals, but we had to make a different fix later in the NEC, in which we'll talk about where we removed some of the demand factors. I think it's back into table 220.42. Because of this reduction here, we had to go back to the demand factors because this task group was very focused on, it was a heavily spreadsheet. It was a spreadsheet heavy effort. And they were looking at where the code is today for different types of occupancies, where the latest ASHRAE code would take it from a VA per square foot calculation, and then sort of where we didn't want to lower the swamp too much. So we made adjustments here, but then we had to adjust the demand factors over in 220.42, which we're going to talk about. So a lot of these went down. The manufacturers, unfortunately, manufacturing facilities are at 2.2, and they were at industrial commercial buildings, lodge rooms, office buildings. So if you did warehouses, they were at a quarter. Warehouses now are at 1.2. So that went up. A warehouse storage facility went up. They realized that there's a lot of lights in warehouses. The demand and the VA per square foot's much higher there. What else? That sort of hit us kind of hard, but that's okay. That's what we do. Good with that. All right. So what else? Courtrooms. So just be mindful that those changed. I'm not sure how many people actually use the 220 table, 220.12. I talked to a few consulting engineers that they'll tell me they don't really use that table. They know they're meeting it, but they work their way up through all the lighting load calculations and they just work their way up to the service from the systems that they use. I don't know where you guys are at with regard to 220.12. Now, another thing that we did, if you look at the note, it says there's a note right under. Remember, notes of tables are enforceable, and it says the 125% multiplier for a continuous load, as specified in 210.20a, is included when using the unit loads in this table for calculating the minimum lighting load for a specified occupancy. So we worked in the 125, which I've gotten good and bad feedback on that. The confusion arises when you're doing your feeder calculations in 215 for ampacity. And remember, and we're going to talk about this a little bit later as well, because we changed, we made it more better. That's a technical term. But if you look in 215, we modified the calculation of the ampacity of feeders a bit. And I believe that's in 215.2, which what do we know about 215? What do we know about .2s? Boy, it just dawned on me. .2, what is that reserved for in the style manual? Anybody on chat? Dawn will know. Yes, Keith, definitions. And I'm looking at 215.2 that says minimum rating and size. I believe that is a violation of the style manual. So, Nihad, we got some work to do, buddy. I don't know if Abbasi's on the phone too, but we're going to have to see how we can remedy 215.2 and make that a different number. But in any case, 215.2 talks about minimum rating and size for feeders. And remember, it says in here, it says where feeder, you have to meet one or the other, A or B in this. And we're going to talk about this later, but just suffice it to say that a feeder, you're going to include the 125% in one of those calculations, and you're not going to include it in another equation. And I've gotten a lot of different questions saying that we, because we put this 125% in the load calculation, that sort of screws up our 215.2 a little bit. You're going to have to back that 125% out, and I would have to agree with that. But in any case, and we're going to have to take another look at that in this next cycle. I don't know if that was such a good idea. It seemed like it at the time. So that's what we did so keep in mind, all of those VA per square foot's changed, and what drove that was the lighting and LEDs and all that good stuff. Now because we made that change in 220.12 and reduced those multipliers, we had to come over here in 220.42 and change the lighting load demand factors, because it just, it just made it look, we were taking too much of a bite out of the loads. And it just made a lot of us on panel 2 a little bit concerned. But we had good justification because we had a lot of data from ASHRAE. And so what we did was we modified the first for hotels, motels, including apartment houses with provisions for cooking by tenants. We modified the demand factors. We moved them up from 50 to 60%, from 40 to 50%, and 30 to 35%. That sort of helped. There was like, I guess you call it almost like a governor, right? It just sort of helped us modify the load profiles, and that was really driven off of some spreadsheets and plots for these types of occupancies. Now, what you don't see in this, what you don't see in this dialogue is the hotels and motels. I'm sorry, not hotels and motels. You definitely see hotels and motels. What you don't see are the hospitals, because we removed the demand factors from the hospitals because we lowered the VA per square foot. And in reality, if you think about a hospital, they're very light intensive anyway. And so with regard to the lighting loads and whatnot, we gave them a break on VA per square foot for the lighting loads, but we took this off, and it sort of balanced them out. I believe it's almost like a net zero for those applications. And right, wrong, or indifferent, that's sort of what we did. And it works out mathematically. It works out from a demand, from a load profile perspective. Now, I know the healthcare industry is also looking at the receptacle loads. So their concern, especially if you think about how we do the receptacle loads, we count how many, we do a VA per receptacle type of deal for the load calculations. And if you think about a hospital operating room, they pollute those rooms with receptacles. And then the argument was made that they don't use all of those receptacles, and it's an artificially inflated number. So there is a research foundation effort going on right now to look at receptacle loads and determine whether or not there's anything we can do with regard to lowering some of the numbers with regard to the receptacles from a load calculation perspective. That is an ongoing study where they're actually doing measurements out in the field on office buildings and in and around hospitals and things of that nature. The healthcare guys tried to make a change in the load calculations this past cycle in Article 517 and in 220. So Code Making Panel 15 and Panel 2 both saw public inputs. Panel 2 rejected those. Panel 2 rejected those public inputs because we had a lot of concerns around the data that they were using and whether or not that it was under the worst case scenario. So, examples were provided where you have events like that are going on today, where we have our hospitals. We're pushing our hospitals when you have these types of events. We have a pandemic going on. We've got a lot of people in hospitals. We had if we have events like catastrophic, like you have tornadoes, you have earthquakes, you have all of these natural disasters that will push our hospitals to the extent. And there were pictures from the state of Washington and in Portland, Oregon, and et cetera, where the hallways were lined with gurneys and people who were plugged into receptacle outlets all through the hospitals. So we wanted to get we just want more data before we feel comfortable in lowering the calculation around receptacles loads in these types of units. So that's why that work is going on. And so, for example, this was in the substantiation for deleting those factors. This was what the submitter supplied as an example. They took a 500,000 square foot hospital requiring electrical distribution size to handle 1,000 kVA of lighting based upon the 2 VA per square foot on the 17 code. And then if you did that with the demand factors, you'd end up with about 200 kVA of lighting with regard to the 2017 version. Utilizing the 2016 version of ASHRAE, the average hospital lighting load is about 0.94 watts per square foot, which means that the example of 500,000 would yield us about 470 VA of lighting, assuming all lights were on. Comparing the demand of 200 kVA after applying the derating factors in the 2016 with 100% connected lighting load, again, it assumes that 42% of lights are on in the hospital. Making all of those changes, we just his example just kept going on to show that that the comparison between the two didn't quite jive. So we justified removing that table in 220. So that's sort of, and there's a lot, there was more to that. I just grabbed those 6 bullet items out of that. Now, what we know, and going into all of this, we knew that lighting represented about 22% of the consumed energy in the United States. So there is a lot of focus around reducing the footprint of lighting loads. There was a lot of data that talked about how much energy usage for type of structure, and you'll see commercial is 51%. We focused in on that 51%, and then you could see how it's broken out with regard to incandescent, fluorescent, high intensity discharge, your solid state LED lighting, and et cetera, for the different types of occupancies. And that's important. And the reason I say that is it's important is because we talked a little bit. I mentioned a little bit about the, or did I? Power factor. Yeah, I did. We talked about VA versus watts. The energy codes love to talk about watts per square foot, but we don't use watts per square foot when we size equipment. We know that if we can save 1 watt, we reduce electrical production by 2.5 watts, and energy saved to reduces greenhouse emissions. So there's an energy usage play, and there is what do you call it? There's an energy usage play and emissions, green, sustainability. That's the word I was looking for, sustainability. Now, here's the issue. When we talk a lot about load and energy savings from things like compact fluorescence and LED lighting. If you're in some of these industrials where you get billed for power factor, there's a hidden cost in here that nobody talks about. Now, if you Google power factor and LED or power factor and fluorescence, you'll find IEEE documents. You'll find EC&M magazine articles and other similar trade magazine articles on this topic about the hidden costs around these solutions, because we make an assumption that our bills are only on watts, where in reality, a lot of our bills, we get penalized for power factor. And what I've learned is that power factor of a lot of these loads varies. It's not unity. If you look, and we missed it in this we had it in our task group work in 220.12. We put it in the task group work, and we put it in, it was supposed to be in the National Electrical Code, but we missed 2 things in 220.12. Actually, 3 things were missed, and I'm not sure if it was a Terra issue, if it was an NFPA issue. It was definitely in our task group results and what we all voted on. There are 2 VA per square foot that are at 3 VA per square foot, schools and universities and sports arenas. Those were not supposed to be 3 VA per square foot. I think they were supposed to be like somewhere down around 1.5 or 1.6. I don't know the exact number, but those were not supposed to be 3. They were supposed to come down. Somehow that was missed. And in 220.12, the informational note says the unit values of table 220.12 are based on minimum load conditions and 100% power factor. That was supposed to be a 0.8 power factor, 80%. And the reason I say that is because we did an investigation. Remember, I got the nickname Mr. VA out of this task group work. And my point was that these compact fluorescents were not at unity power factor. LED lighting is not at unity power factor. In fact, compact fluorescents and your fluorescent lighting in general can be as low as 0.5. And if I'm showing you 100 watts with a power factor of 0.5, my VA is actually twice that, because I have to take 1 over the power factor and multiply that, which 1 over 0.5 is 2 times. So it's really 200 VA. And that's how we would size our equipment. So we had to make an adjustment to the ASHRAE numbers, because ASHRAE works in watts per square foot. They don't think about VA. We in the National Electrical Code, we think about VA. That's how we size equipment. So what we argued and settled on was a 0.8 power factor, realizing that if you bought the more expensive compact power CFLs or more expensive fluorescent lighting, you're going to be probably up around 0.9 and maybe a little bit better than 0.9. In fact, to have an Energy Star related lighting product, you have to be greater than 0.7. I think it's 0.7 or 0.75. I got it in my presentation here somewhere. But I did find that a lot of these less expensive fluorescents are at 0.5. And we all know where in our industry most of our solutions get bought at. They come from low bidders, and they're not buying the more expensive fluorescent tubings. They're going to be buying the less expensive ones. So, but in any case, and then LED lighting, I did a lot of research on LEDs, and they talked about the natural state of an LED circuit could be as low as 0.3 power factor, not, again, less than 0.5, but most of the LED lighting that I've seen, usually they're Energy Star, and they are greater than 70. There it is there. So to get an Energy Star label on a lighting solution, less than 5 watts, there's no minimum power factor requirement. But if it's greater than 5 watts, then you have to have at least a 0.7 power factor. And what I'm seeing, a lot of the LED lighting is around 0.9 or greater than 0.9. And this is a study that was done. I can't remember. I have the link, I think, in the information in where this came from. But there was some research done and testing done where they actually connected LED replacement lamps, and they measured a power factor of 0.63 average, and then the range was anywhere from 0.57 to 0.77 power factor on those floods or on those types of lighting solutions. And this is a 1400 milliamp LED driver that you would see in like a ballast replacement or whatnot that you would see in a lighting fixture, and you'll see that the power factor ranges anywhere from 0.8, so that if you're at 480 volts, from 0.8 up to 0.96, depending upon the output power of the solution. So I put this stuff in there simply because I just want to raise the awareness, and I never realized it. I always assumed unity power factor on a lot of this stuff, but a lot of our lighting, you got to be careful. They always love to talk about watts per square foot. They love to talk about reducing that W. But especially if you're in an industrial, the utilities are going to charge you for VA as well. They're going to charge you for power factor, and you've got to think about the higher the power factor, the more efficient use of the energy that you're providing, and especially if you have a lot of these things that could save you money, spending a little bit more on these fixtures to make sure that you get the higher power factor. And I don't think you want to get into the practice of applying power factor correction locally. In any case, that's all I have to say about that. So let's move on to 408. I'm just going to check real quick the chat sessions, take a look at some of the chats going on WebEx. I'm going to move this. Look at this. The guys on YouTube don't get to see this usually. So I'm going to show, it just dawned on me today that I can show the chat on YouTube by just simply pulling the chat over here. So could you show an example of how to properly use the values from 220.12 and 215 minimum feeder sizing since you have now absorbed that? You know what I'm going to do, Chris? I am going to do that in a separate program on just doing some sample load calculations. It's going to take me a little bit too much time right here. And I don't have any, I do have a load calculation prepared. It's more of a residential focus. I'm going to update that to do more of a commercial focus, but I'll do that in a later seminar. Does the 22% lighting load include the future transition to LED? So Gabe, the one trend that I showed, the one showed that they did break out the different types. So I believe that 22% includes at the time of that study, the LED lighting, but it doesn't necessarily show what's going to happen in the future. In the future. Good question. Attendance. Do we need to check in Menti for attendance? If yes, can you please send the code? The code, somebody please. I know it's up above. If you You scroll up and you will see the Menti code right there. Copy, and I'm going to update that for my chatters out there. Control V. You see how easy that was? Bam. Done. All righty. Those were the questions I had there. And let's take a look on the web, on YouTube. Steve Froming in the house, y'all. Brian Chambliss. Okay, awesome. There's Florida West Coast, David Platt. Quiz does not keeping track of individual scores. That's true. Yep. It was my device. Finally, a BNB. Okay. Thanks, David. So everybody seems to be answering their own questions out there on YouTube land. That's a good thing. All right. So I am going to move. I'm going to take this party over to 408. And if we remember, 408 is switchboards, switchgear, and panel boards. Thank you very much. 2020. And I know Larry loves when I use this word, journey. NEC 2020 continues the journey that the 2017 NEC began with a marking of available fault current on equipment. So yes. Oh, that code was wrong. Charles Gertz, the code 80. Hold on. We got a code issue. We got a Menti issue. 801287 is good. 12287 is not good, Charles. Change that 122 to 12. All right. Okay, so 408. Remember, 408. We had a marking. And I'm going to cover all of the different marking requirements, but we now have to field mark available short circuit current or fault current on all of our panel boards, switchboards, and switchgear. And again, it's all about the proper application of equipment, whether it's 110.9, which is interrupting ratings, and 110.10, which focuses on short circuit current ratings. The right recipe in general, the recipe to properly make sure you are applying a product correctly with regard to available fault current is to first, you have to make sure that you know and understand the rating of the equipment, and it's great to have that field marked. Second, you need to know that you can, what the available short circuit current is, and remember, it's the symmetrical fault current, maximum available at that equipment, at the line terminations of that equipment. And then third, you need to compare those two. The SCCR rating, the short circuit current rating, has to be greater than or equal to the maximum available short circuit current, and that is a symmetrical evaluated current that we're looking at, right? So the NEC relies, in my opinion, relies heavily on the listing and labeling requirements of products that we install in the field. For the most part, most of that equipment is going to be required by the listing to market in the field. I'm going to educate you a little bit on how panel boards and switchboards are marked differently. But in the marking, when you're looking at the 17 cycle and the 2020 cycle, there's a mix. Some of them require that you field mark the available short circuit current. Some of them require that you just have documentation available. And the difference there is the reason one is marking and one is not. It's because two different code panels. One code panel thought it was important to field market. The other code making panel thought it was more important just to have it as available as documentation. So they didn't go to the field marking. We're going to talk about that as well. And then remember that that comparison has to be made, and that will probably be made, hopefully will be made, by your authority having jurisdiction or possibly the installers. Now, this is everywhere in the NEC where we have a marking requirement for short circuit current rating. And I think I'm going to go back to 408 because I may have missed a section in here. Let's take a look at what 408 tells us. In 408.6, which I'm opening the book. I believe that whole section is new. Yes, it is. That whole section is new. So 408.6 probably should be added to this because it says switchboards, switchgears, and panel boards shall have a short circuit current rating not less than the available fault current. In other than 1 and 2 family dwelling units, the available fault current, okay, no. 408.6 does not require that the panel board, switchboard, or switchgear be marked with the short circuit current rating. Interesting. No, it doesn't require. Okay, so I don't have to update this slide. But we're going to talk a little bit more about that anyway. So in any case, and that could be a good public input because I mean every other area says you have to mark it field, you have to have it marked, you have to mark it with the short circuit current rating, and there, it's probably this discussion it needs to be had, and I'll explain to you why it's a little bit more complicated with those type of equipment. But in any case, all of the equipment that you see here, all of the transfer switches in 700, 701, 702, 708, they're going to have special requirements. In the 17 cycle, we have to mark the short circuit current rating of that equipment because the short circuit current rating of that equipment is dependent upon how it's installed. What is supplying it? They call it an actual withstand close-on rating, but in any case, the short circuit current rating or the withstand close-on rating is going to be dependent upon the overcurrent device that's upstream from it. We'll get a little bit of that discussion because I think there's a similar issue that we have with 700 and with a transfer switch that we'll have with panel boards and switchboards. But in any case, we'll cover that one a little bit more. The elevator control panels, industrial machineries, those are, and air conditioning, those are all types of UL 508 type of equipment, industrial control panels that will be marked with a short circuit current rating if it's a listed control panel. Motor control centers, motor controllers, industrial control panels, all of these will have the short circuit current ratings marked on them based upon the standards to which they are listed. Another value of buying a listed solution, even if it's not required, you know you're going to have the necessary information. Now, this is where you either have marking or documentation of available short circuit current. This is my slide from the 2017 NEC. 110.24, we had that as listed as changing because 110.24, although it had a marking requirement, it was you were required in the 17 cycle to actually document how you got that information. So you were already required to mark the available short circuit current, but we just said now that you have to have documentation on how you come up with that information. And then the stuff that's in 409, 440, 620, and 670, that's all new for the 17 code cycle, where you either have a field marking or a documentation of available short circuit current or available fault current for each of those equipment. And that cannot be put on in the factory. That's all going to be field marked because, for obvious reasons, short circuit current's dependent upon the impedance of the system within which it's installed. Now, what's new for the 2020 cycle is 408.6, the section titled Short Circuit Current Rating. Now, if we remember that's 408.6, and that's 408.6 is in part one, to make sure that 408 is separated. 408 is separated into parts, so we know that 408.6 is indeed in part one, which is a general requirement. And then the scope of 408.1 covers switchboards, switchgear, and panel boards, but they note that it doesn't apply to equipment operating over 1,000 volts except as specifically referenced anywhere else in the National Electrical Code. So we know that this marking is general for 1,000 volts and below equipment, and the language reads like what you're seeing here. Panel boards shall have a short circuit current rating not less than the available fault current. In other than 1 and 2 family dwelling units, the available fault current and the date the calculation was performed shall be field marked on the enclosure at the point of supply. The marking shall comply with 110.21b3. So the key thing here is, and it's dawning on me that there's no requirement in 408.6. I mean, that would be where it's at. There's nothing else in here that says that it has to be marked with its short circuit current rating, but it does say it has to be marked with the available short circuit current. And I could be wrong, unless somebody out there knows somewhere else in here that says in the code in 408 that it's marked, but I'm not seeing it. I could be missing it. I'm just looking through 40 panel boards. Let's take a look at panel boards. In addition to the requirement of 408 to 30, a panel board shall be protected by an overcurrent. That just talks about protection. Because part 2 is panel boards. So let's look in part 2. Snap switches, supplied through a transformer, backfed devices, damp wet locations, grounding of panel boards, panel board orientation. No, there's nothing in part 3. Part 3 is panel boards. There's nothing in part 3 that says that I need a marking of available or marking of the short circuit current rating. So opportunities are all around us, as my friend Donnie Cook tells me. All right, I already said this. All right, so switchboards, switchgear, and panel boards shall have a short circuit current rating not less than the available fault current. Now, or available, fault current. So let's talk about the short circuit current ratings. This is the language from a panel board label. Now, what you'll notice is, let me get this. I'm gonna write. So it says right here, the short circuit current rating of this panel board chassis is equal to the lowest current interrupting rating of any device installed, except as noted in the series rating information manual attached. Now, panel board, if this is the case, if it's the lowest current interrupting rating of any device installed, that tells me that when you put this in the field and you buy the breakers that go in that panel board and you put them in, you are determining the short circuit current rating of that assembly. So imagine you did it all right, and this is you did it all right on installation. Every interrupting rating of every breaker in that panel board is 22K. The short circuit current rating of that equipment is 22K. And then you go to the supply house because you're going to add a new breaker and you say, hey, I need a 20 amp breaker. What do you think they're going to throw on the table? A 22K breaker or a 10K breaker? They are probably going to give you a 10K breaker and not a 22K breaker. And the moment you put that breaker in this panel board, you just reduced the short circuit current rating from 22K to 10K. So the rating of this equipment is really determined in the field and how and what you're installing in that equipment. That's an important thing to remember, and I don't think we think about that when we go to the supply house and we start ordering overcurrent devices. And then the electrical inspectors, a lot of your electrical inspectors are going to be looking at all the interrupting ratings. And now that we're going to have an available fault current marked on the outside of them, you're going to have to make sure that all of the interrupting ratings are greater than that available fault current, and that will establish the short circuit current rating of that equipment. Now, switchboards have a similar label, and this is the information that we give for switchboards. The short circuit current rating of the switchboard section is equal to the lowest interrupting rating of 1, any section electrically connected in series, or 2, any installed panel board having a marked short circuit current rating, or 3, any device installed except as noted in the series rating information, and 4, 42 kA max for any lineup containing an RDC feeder device, NATSAR type of circuit breaker. So that is specific to our manufacturer. That's an RD and RDC circuit breaker mounted on the distribution chassis. So we don't really give you the SCCR, but what we give you is a recipe on how to achieve, or how to calculate the short circuit current rating of that equipment. So it begs the question on whether or not we should have, when you install it, what your intention is to be labeled, field labeled on that equipment. I don't know if that's needed or not. I think you might see a public input next cycle, but that will be good fodder for discussion, because I don't think a lot of people realize that you're going to change the short circuit current rating of that equipment when you install these devices. Now, just to talk a little bit about the short circuit current rating. A short circuit current rating is the ability of this product that you're seeing to withstand the current passing through it. So for a fault downstream, so if I have a source coming from a source and I have a fault downstream, all of this equipment has to deliver that fault current. Anything that is in the current carrying path has to hold it together under the magnetic forces until the overcurrent device up above clears that fault. That's an important thing to remember, that it's the short circuit current rating is not stopping the flow of current. Circuit breakers have an interrupting rating. They don't have a short circuit current rating. Electrical equipment, distribution equipment like this will have a short circuit current rating. And this is what happens when you exceed the short circuit current rating. So the fault is actually down here, not inside that equipment, but this equipment saw more current than what it is rated to handle from a short circuit current rating perspective. And, you let the smoke out. We did a few more tests on different type of equipment. So that looks like my shirt after a good Thanksgiving dinner. But you'll notice that the actual fault, we bolted the circuit downstream of this equipment, and it just could not pass through. All right. Sorry about that. So this is, again, 5K equipment. So that door on that one actually flew about 20 feet across the floor. And it just to coach this a little bit, this is misapplied equipment. This is a 5,000 amp short circuit current rating, and I'm hitting it with well above 5,000 amps of current flowing through it. And what you're seeing is, as Dan Neeser says, an unintended rapid disassembly in the field. You let the smoke out because it's misapplied product. And this last one is a plastic enclosure, 35,000 amps of fault current passing through it, and it just can't hold it together under those magnetic forces. So when you misapply a product, whether it's the short circuit current rating or the interrupting rating of an overcurrent protected device, you are going to have an unintended rapid disassembly in the field. You're going to let the smoke out.
This is a serious misapplication.
And it is indeed a serious misapplication in both of these cases, because we hit a 10,000 amp interrupting rating fuse and a 14,000 amp interrupting rating breaker.
This is a serious misapplication.
With 50,000 amps. they're not rated to stop the flow of 50,000 amps. Proper application is very important. To follow the instructions of the manufacturers, look for understand the short circuit current that's available at the equipment, and look for the labels that says short circuit current rating and what it's capable of. These all have a short circuit current rating. This is busway. It's a blank label, but you'll notice over on this side here where we'll tell you when protected by a specific overcurrent protective device, whether it's a fuse or a circuit breaker, and we'll tell you the exact size it needs to be. And we'll tell you that the SCCR is what type of what current and what type of short circuit current rating we have in regard to the rating of this equipment. So it's an important aspect of proper application of these devices is to understand what the available fault current is, what the capabilities of the products are, and then do that comparison. And in the case of a lot of these devices, they're going to be dependent upon what overcurrent device is applied upstream or internal to, say, a fusible switch, for example. What fuse you put in there could be critical to understand what the short circuit current rating of that equipment is, because that fuse and the current limitation of the fuse and the circuit breaker is what's going to get you that rating. You have to put the right devices. Don't confuse short circuit current rating with interrupting rating. The short circuit current rating is the rating of the equipment. The interrupting rating is the ability of the overcurrent device to stop the flow of current. Receptacles even have a short circuit current rating. You'll see down here it says a short circuit test meets and exceeds 10,000 amps. That's your withstand rating, because these devices are going to have to hold it together and supply that fault current to whatever it is it has the fault downstream, whether it be an appliance plugged in or the conductors connected to the load terminations of this GFCI receptacle. The contacts and the electronics inside are going to have to hold it together while that fault current passes through it. UL 508A has a table, which I have a love-hate relationship, because it talks about the short circuit current default SCCR rating, and what do we learn? We just learned that circuit breakers do not have a short circuit current rating, right? Fuses do not have a short circuit current rating. So we got some work to do on this table a little bit, but in any case, you'll see that there's default SCCR ratings for things like receptacles and whatnot, and supplementary protectors and switch units. When that's a default that, if it's not labeled, that's what you go with. All right. So, and then in 430.99, there was a real subtle change, which I'll just mention here, that this was new for the 2017, that the available short circuit current at the motor control center and the date the short circuit current calculation was performed has to be marked and field marked on that equipment. And again, it works in conjunction with 430.98. And this was the minor change that we did. It's not the short circuit rating, it's the short circuit current rating. Very minor change, doesn't change the intent of this, but it does cause us a moment to go back and review that motor control centers, those buckets, motor control units, all of that has to be applied correctly with regard to the available fault current. And they'll have the withstand capabilities rated, and they'll tell you how many cycles that equipment is. So if you have a short time delay breaker upstream, you've got to make sure that you clear that fault fast enough to make sure you stay within the ratings of that equipment. And again, in the 2008 edition, introduced the marking of the short circuit current rating, and then in the 17 introduced the requirements to be to have the available fault current. So 430.8 has been in there, and it's that line item 4. Again, that was a part of the 2008 version, so we should be very familiar with that, which is automatically done when you buy a listed solution. And then for SCCR, for the SCCR rating, the markings, there are some exceptions to for an SCCR in 430.8. That's controllers on motors 1/8 horsepower or less, and then 1/3 horsepower or less. And you have to see 430.81 to get those two requirements or those limitations. And then controllers rated less than 2 horsepower, not required to be marked when the marking is already a part of the controller. All right, so these are your standards. This is your standard. So the marking, this is the recipe. So, you know, the first part of that recipe is right there. The SCCR has to be marked on the equipment. It's a requirement in 430.98, and it is a part of UL 845. The second part of that recipe is to know your fault current, and that's required to be documented, not field marked, documented as part of 430.99. I believe I said field marked earlier. It's not. This is a case of documentation only. And then I think and then you have the third line item is NEC 110.10, which tells you they have to be compared. Now, I believe Dan Neeser, who is on code making panel 11, just could not get the marking requirement put in there for this. So kudos to Dan, or opportunities to Dan, I guess. I think he is online. I just see him commented to 2005 NEC introduced it. I'll have to check my slide, make sure it's accurate. Thanks, Dan, for keeping me honest there. All right. And so now let's talk a little bit about selective coordination in 620. Now remember, 620 covers dumbwaiters, escalators, movie walks, platform lifts, stairway chair lifts, and elevators. I should have said that one first. So this is related to those types of applications. Now the code changed this underscore. See where it says where more than one driving machine disconnecting means is supplied by the same source. That used to say supplied by a single feeder. The implication here, the significance of the change, it aligns with other areas in the NEC where selective coordination is required, and it moves its way back up to all over current protective devices on the supply side. So again, the previous language only required selectivity for those supplied by a single feeder. Now we have from multiple feeders are installed or in that application. That does the expansion. That's right, Dan. You're on CMP 13. That's right. Sorry about that, buddy. That was Joe Shoemaker. Joe Shoemaker's on panel 11. Yep. You gotta stay of execution, buddy. Selective coordination shall. Now these two exceptions came in because we pulled those in from the Dan Neeser guys, the panel 13 guys who have Article 700, 701, and 708. They pulled in those requirements to align with all of those areas where we have selective coordination requirements. That it's, this basically says, and again, my recipe for determining what devices need to selectively coordinate, you simply have to figure out if a downstream device opens, what load does it take out? If the device directly upstream opens, what load does it take out? If they both take the same load out, then you don't have to selectively coordinate them. If taking out the upstream device takes out more loads than the downstream device, then you do have to selectively coordinate. An example of not requiring a selective coordination is on the primary side of a transformer. That overcurrent device does not have to selectively coordinate with the device directly on the secondary of that overcurrent device. Hopefully that makes sense. And then shall not be required between overcurrent devices of the same rating in series with each other. So if I have two 100 amp breakers or two 100 amp fuses and they're in series with each other, they take out the same load, I don't have to worry about coordinating those two. Now, what happened in the 2020 cycle? Yeah, Dan, I agree. There probably should have been one exemption in the performance language like we did in 700, 701. So opportunity for next cycle. Now, here's the difference that we did in the 2020. They realized that the devices in these applications in 620.65, they added new language that basically says that when you have a system that is selectively coordinated, devices that are selectively coordinated, we have to raise the awareness to maintenance individuals and anybody after the fact that those devices have been chosen for a specific purpose. And if there are set points on those devices, they are programmed with a specific purpose in mind. If we are going to replace a device in the field, it has to be selected and applied with that in mind. Because if you pick the wrong device and you replace it with something different, you probably will completely destroy your selectively coordinated system. And the reason is because I'll sell 3 or 4 fuses that have the exact same amp rating, but they are different. They're built differently. I have 3 or 4 different circuit breakers that probably will fit in that spot inside that panel board, that will legally go in that panel board. They have different trip characteristics. They'll have different set points. They'll have different performance based upon the selective coordination tables. So the guys and gals that sit on this code panel recognized, and they said that you need to have a marking that says overcurrent devices in this enclosure are selectively coordinated. Equivalent replacements and trip settings are required for that reason. We want to maintain the coordination of that equipment. All right. That's all I have to say about that. 645. Now, 645 was in selective coordination was introduced in 2014, and it's again driven by reliability. Selective coordination is focused on reliable power distribution systems and making sure that the downstream device trips before the upstream device does. And in information technology equipment and those applications, they care a lot about making sure they don't take parts of their distribution system down without due cause. So they care a lot about that. And again, you have to look at the definition, but what they did here was again correlate these requirements with other areas of the NEC, where we say that it has to be selected by a licensed professional engineer or other qualified person engaged in the design and installation, and then again and made available to the AHJ. So we're bringing these in alignment with the other areas of the NEC. Not a big change, other than you got to know what you're doing when you do these studies. It's not easy, as that quiz demonstrated. There were a majority of those on the phone that would say that BAB breaker downstream of that F-150, the breaker, not the truck, selectively coordinated, without knowing that they've got to compare available short circuit current. And if you don't know what the selective coordination tables are, go back and watch. I've got 2 videos, one for fuses and one for breakers on my channel. And I have the session from 2 Tuesdays ago that basically talks about selective coordination. You should watch that video as well. Now, here's what we did in 700.32. The parent text of 700.32 did not change. You still have the same language that we just saw. So licensed professional engineer or other qualified person, we just saw that in 645. And then there's the exception, not required between 2. None of that changed. But what they did was they settled the long-lasting debate, in my opinion, of what has to selectively coordinate in the system. The big debate has always been focused on these 2 devices. At least one of the big debates has been focused on those 2 devices, and whether or not they have to selectively coordinate with each other. Keep in mind that, let's take Article 700 as an example. If I wanted to know what devices in this one-line diagram are a part of the emergency system, it would be devices E, F, C, and D. The requirements in Article 700 apply to everything on this life safety side of this equipment. So everything down here, right? So that is where your life safety system resides. Devices A and B are outside of the purview of Article 700. And what Code Making Panel 13, and Dan Easter can contest to this, keeps getting, and Mr. Froming, you, if you're still on this line, you were the instigator of this. You put a public input in saying that these two did have to coordinate with each other, and then you put another public input that said these two do not have to coordinate with each other, and you made Panel 13 address this issue, and they did it in an informational note, which was I think a very good addition, because clarity is very important in these things, because the lack of clarity it gets quotes messed up, it gets the design of the entire system screwed up. So I'm going to walk through this informational note to help you understand what has to selectively coordinate with what. So the first thing they did was they added each of these items here on the left-hand side. So I'm going to follow each of these one by one. The first is overcurrent protected device D. The way the language in the parent text reads, it says, I'm just to make sure I don't mess it up, I want to make sure I'm as accurate as I can. I'm going to go to Article 700, and 700 says, selective coordination. It says emergency system overcurrent devices shall be selectively coordinated with all supply side overcurrent protective devices. So emergency system overcurrent devices. Device D is an emergency system overcurrent device. It has to selectively coordinate with all line side. The fact that A and B are on the normal side, the onus of selective coordination is on D. It has to selectively coordinate with all line side, even that which is even A and B, because it is on the line side. But the onus, the responsibility for selectively coordinating is on D, not A and B. The fact that you have to probably change A and B to meet this requirement is a reality, but what you are doing is trying to make sure that D selectively coordinates with A and B. Now we're going to look at C. C has to selectively coordinate with all line side overcurrent protective devices. It is on the emergency side. So the onus to selectively coordinate with A and B is on C. And I may, again, have to make changes in A and B to meet this requirement, but the onus is on C to selectively coordinate with B and A. Okay, and I will probably have to make changes to B and A to accommodate this requirement. But if you could get it done with making a change to C, get it done that way. But otherwise, you're going to have to address it. And you're always using the maximum available fault current, whether it be from the utility or the generator. Based upon the definition, you can't use the fault current from the generator for these evaluations unless it is greater than what the utility can provide. So, and then finally, the only other two devices on the emergency side is F and E, and they do have to coordinate with each other. Now, those two devices are only going to see the fault current from the generator. So they don't have to selectively coordinate to what's necessarily coming from the utility if that's greater. You would only have to selectively coordinate the devices E and F with the fault current that's available from the generator. Hopefully that makes sense. And then finally, you have A and B. Those two devices although you will probably have had to make a change to accommodate the requirements that are on devices C and D, those do not have to selectively coordinate with each other per the requirements of Article 700 because they do not fall under the purview of 700. Now, there are a lot of design professionals that will make sure A and B selectively coordinate to some level. When I say to some level, they may not pick the three-phase bolted fault current. They may pick the arcing fault current or the ground fault current. They're going to pick something because avoiding the transfer is increasing the reliability of the power system, because the transfer switch may not transfer. This generator is not guaranteed to start every time. I know we go through maintenance, we go through performance testing, and we want to make sure that these things are working correctly on either an annual or semi-annual or some sort of basis. Everybody's systems and your requirements or your operating procedures may vary. Some may do this more often than others, but the fact remains that the moment that you can avoid a physical interaction and starting the generator to supply life safety equipment, if you can avoid that in the first place, the better your design more than likely is. Now, this language, that diagram, was added to 700.32, 701.32, and 708.54. Those are the other three areas where the exact same informational note, the exact same diagram was added so to clarify that long-standing debate. Thank you, Mr. Froming, for that public input. You, I think, finally put this argument to bed. We can put the nail in that one. All right, I'm going to just quickly take a look at the chat session, and I'm going to move this over so, again, our YouTubers can see the chats, because I just remembered this. SCCR is what the entire equipment, including smaller components, can withstand before the overcurrent device interrupts the current flow. We got to keep in mind that the short circuit current rating of the equipment is going to be dependent upon the overcurrent device that is either inside or ahead of it. I liken this to a weightlifter. Think about a weightlifter laying down on a bench, and you're going to put weights on him. You have the weightlifter, you have the weights, and you have the spotter. The spotter is the overcurrent device. The weights are the magnetic forces being placed on the weightlifter, and the weightlifter is the electrical equipment. I can tell you I can bench press 500 pounds when spotted by Lou Ferrigno. So as long as I have Lou Ferrigno standing above me, I can pick that equipment up, and I'm not going to get hurt, because Lou is going to recognize, and he is going to make sure I don't see 500 pounds. I'm going to step up off that bench. I'm going to say, I just bench pressed 500 pounds, when really all of the work was done by Lou Ferrigno. Now, if I laid down on the bench and Dan Neeser was standing over me and said, hey, Tom, Lou's in the bathroom, we got this covered, I'd look at Dan knowing he ain't going to be able to hold up 500 pounds. I can't hold up 500 pounds. One or both of us, probably me, is going to the hospital, right? Because I have the wrong spotter. Same thing goes for equipment. If I have a safety disconnect switch and I'm labeled 200,000 amp short circuit current rating, I will guarantee that 200,000 amp short circuit current rating is achieved because of some fuse in the picture. And if you look at the instructions, it will tell you the exact class fuse and the exact size fuse that you need to put in that picture. Just like I know I can bench press 500 pounds when Lou Ferrigno is there. Nobody else. I've not been tested with anybody else. It's got to be that one individual. It's got to be that one overcurrent device. All right. Yes, Wendell, 2014 NEC handbooks. If there's anybody on YouTube or anybody on WebEx that are part of this, that needs a 2014 NEC handbook because you might be in a jurisdiction, contact Wendell Whistler, WWHISTLER at CJATC.org. He can hook you up. Other qualified persons in regards to Article 700. So again, another qualified person. If I may not be a PE, I may work under a PE. I may have done coordination studies. I may have extensive experience in that area to demonstrate that I am qualified to do that. I just might not have my professional engineering license. They did not want to, in that panel, I know specifically, there were a few at the panel that argued they didn't have their PE, but they were more than qualified to do a coordination study, probably more qualified than some PEs. But they just did not have that license. And they made a very good point, argued a very good point, and they put that in the language. So Bill Neitzel, your comment on the multiple devices fitting into a system is a good point. Yes. Consistent violations we ran into was not that it was designed wrong, but somewhere in the supply chain, the breaker that was specified was not available, and so they grabbed the one that would fit. That is a good example, Bill, and I've seen that myself. And if inspectors aren't looking for it, they may make the assumption. But I'm telling you that the marking of available fault current, the markings of short circuit current ratings and things like that are going to raise the awareness of this. And I think that's why the code panel put these requirements in the later chapters of the book. Would it be safe to say that the available fault current should be shown on a time current curve? Yes, that is very safe to say, Gabe. And in fact, if you look at a lot of the IEEE documents, I would always plot my available fault current on my trip curves. And if I plotted the three-phase bolted fault and said it didn't coordinate, if it wasn't a requirement, I would also plot my arcing fault current. At least I know it today as the arcing fault current, but back in the day, in the 90s when I did that for a living, I would always plot based on IEEE 242, I believe that's the red book. They would give me a percentage of the bolted fault current that they said was the arcing ground fault, the most common fault in a power distribution system. I would plot that value and at least make it coordinate to the most common fault in the power distribution system. And then in my footnotes to the owner, I would tell them that I didn't selectively coordinate at the three-phase bolted fault current, but I achieved a level of coordination that was to the most common fault, the arcing ground fault. The fact that if you do not plot fault current, if you do not take into consideration fault current, then you aren't coordinating anything, in my opinion, in my humble opinion. Someone asked, would it be safe to say, someone asked if marking could be inside equipment. You know what? I would say yes. I don't, it doesn't say on the outside. I know there's some requirements, some ideas in the standards to mark on the outside, but there's nothing that says where it has to be marked. It just says it has to be field marked. Yep, arcing ground fault as a percentage. Yep, Gabe, that's what I used to do. It got me out of some hot water, and then I let the end user, I let the customer, especially if it's not an Article 700 system. I did some commercial systems, industrial. I did industrial power distribution systems, and I did also some nuclear. But nuclear, I selectively coordinated like you're supposed to, and I didn't cut those corners. So, all right, it's looking good. We've got almost 300 people online. That's great on YouTube. So let's move on, and we shall continue on to 445. 445, disconnecting means an emergency shutdown. The requirements, the changes you see in this, in 445, which again, this is generator applications, installations. The requirements that we see here lined up with the changes that we saw in 230. regarding the, remember I called it the firefighter disconnect. They're calling it the emergency disconnect, an emergency shutdown. This is for your first responders. And so aligned the requirements in 445 to shut this generator. So if you have a generator on site, an external generator, you're going to have to make sure that you can disconnect the service, but we all know what happens when you disconnect the service. The generator is going to start, and you need to shut down that prime mover. So in A, disconnecting means, we basically said, each disconnecting means shall be lockable open in accordance with 110.25. You'll notice it doesn't say only lockable open. It just says lockable open. If my switch is lockable closed, I would not be violating 445. And then in C, they made a change. They said that they said generators with a greater than 15 kilowatt rating shall be provided with a remote emergency stop switch to shut down the prime mover. The remote emergency stop switch shall be located outside the equipment room or generator enclosure and shall also meet the requirements of B1 and B2. And to refresh your memory, B1 and B2 says it has to be equipped with provisions to disable all prime mover start control circuits and requires a mechanical reset. And it'll have to require a mechanical reset. Okay. And then finally in D for emergency shutdown, this is what aligns, with what happened in 230. What you'll find is when you start showing the love to a section because of some reason, you start to clean up other areas in that section because people start to look at it with new eyes and they go, why, we need to either clarify or fix some of the language here. But this was the prime intent in 445.18. Emergency shutdown in 1 and 2 family dwelling units. Again, if it's a permanently connected type of generator and not cord and plug connected, you've got to be able to shut that thing down in a readily accessible location. Falls in line with the introduction of 230.85. That's the section where we had the requirement for the emergency disconnect, which I was calling lovingly the firefighter disconnect, which is there for first responders. And again, the other areas you're going to see, and we're going to cover 480.7 because there's a requirement there. And I threw in 690.12 because in technically 690 was not a part of the firefighter disconnect discussion and code changes, but it does relate because the rapid shutdown is really there for the first responders and firefighters that have to get on that roof or when these photovoltaic systems are on roofs and installed on roofs. So you have a couple things that were already covered and a reason why we didn't have to make any changes to the Article 690. You have this rapid shutdown, and when you kill the utility, a utility grade inverter, the utility interactive inverter, not grade, utility interactive inverter will automatically shut down and not provide any power when you kill the utility. So not that we want to kill utilities when we cut power from the utility. Sorry about that, Mr. Croushore. Any case, when the rapid shutdown's already taken care of, so I just put that into basically, address the questions before they arise, because that always comes up. And then it says, again, this was new in the 2017 cycle, but we relocated it into a renumber. So this, in your book, it will be underscored, I believe. I'm just going to check in 445. 445.18. 445.18E. No, good. They didn't change anything on that. But I think in, if I'm not mistaken, it was, I'm just going to check I'm checking the 17 code, 445.18. 445. Yeah. So 445.18E is generators installed in parallel. And in the 17 code, it was 445.18 Charlie C, generators installed in parallel. So in TerraView, if you go out to TerraView, you'll see it underscored. It is correctly not underscored in the 17 cycle, in the 2020 cycle, but they did renumber it from Charlie to Edwards. So if you were looking for it, it's just moved, not new language. 480.7, DC disconnects. So just like we had in generators, they had to, when they were looking at all of the different, what do you call it? All of the different areas where you had power that was being supplied to the system, whether it be a generator or it be a DC system, things of that nature. They had to address all of those separate sources. So the article, they went back to 480, which deals with stationary installations of storage batteries. And they said that you have to have a disconnect for 1 and 2 family dwellings. Disconnecting means or its remote control for a stationary battery system shall be located at a readily accessible location outside of the building for emergency use, and it shall be labeled emergency disconnect. Now, I don't see any grouping requirements. It just says to be disconnected outside. I'm going to look at 230. I'm going to look at 230.85. I don't believe there was any grouping discussion in 230.85. 230.85 says, for 1 and 2 family dwelling units, all service conductors shall be terminated in a disconnecting means having a short circuit current rating, blah, blah, blah. If more than one disconnect is provided, they shall be grouped. Each disconnect shall be one of the following. So it says that for emergency disconnects on service conductors. But it says they need to be grouped for that, but it doesn't really, in my opinion, address the DC and the generator, saying that you need to group all of those together. And I don't see anything in 445 or 480. So I don't know if anybody out there in YouTube land or in chat land on WebEx has an opinion on that, but in my opinion, I don't see any reason that you would have to group all of those together. David Shapiro talks about 705.10. Let's take a look at 705.10. Because remember, 705 is interconnected electric power sources. So 705.10 says, identification of power sources, a permanent plaque or directory shall be installed at each service equipment location or at an approved readily visible location. The plaque or directory shall denote the location of each power source disconnecting means for a building or structure and be grouped with the other plaques or directories. Okay, so multiple sources of power. So 705.10. Thank you, sir. Mr. Shapiro. I'm going to add that to my slide deck for future. You see that? This is I'm going to write 705.10. And you know what? My slide decks are like the code, which is also like a fine wine. They just get better with time, So I have to remember to add that. I don't have a Mr. House that I can say, Brian, just update this. It's all on me, baby. All on me. So again, these are the other related requirements, and I would say 690 as well. I didn't put that in this slide, but I believe we have 690 covered by rapid shutdown. Not rabid as RABID. That would be a really mean shutdown. This is rapid as in RAPID. I don't want my Pittsburghese to get in way of anything. Now here's another interesting one, because we had a debate, and I don't think I covered this one, But I had a debate over in Massachusetts with an inspector at one point. They talk about in 620.51 that a single means for disconnecting all ungrounded main power supply conductors for each elevator. It has to be there, etc. And this is the language that they changed. That is lockable only in the open position. That means that if you have two holes in there, one where you can lock it in the open position and one where you could lock it in the closed position, this is like the only area that I'm aware of in the National Electrical Code where that would be prohibited. It can only be lockable in the open position. So you'll notice in this disconnect switch that you can lock this in the open position, but there's no hole equivalent up here that would make it such that you would lock it in the closed position. So this would meet the requirement of that version of the NEC. And the last thing I want to cover, I believe this is the last thing, is this is the ampacity discussion I mentioned earlier. We did some cleanup a little bit, branch feeder circuit conductors and output conductors. Circuit conductors on the output of an adjustable speed drive system are susceptible to breakdown under certain conditions due to the characteristics of the output waveform. So we have to consider those conditions, and we have to make sure that we protect those conductors in light of the inhospitable conditions that we are going to put them in. In 431.22b, we provided an exception to the 125%. When it's suitable for output motor conductor protection when the conversion equipment. So there are some variable frequency drives and some drive equipment that will say we will protect that and give you, they'll be listed for that, and they give us a separate way to ascertain the ampacity for the calculation of the minimum size and ampacity of those conductors. So you're looking for that. And this did not change, but you're looking for that equipment that has to be rated to provide that protection. Conductor supplying. So again, using the rated input current of the power conversion equipment as the considered full load motor current for the purposes of so they made some changes in this area because the drive equipment is getting better and changing. We have to change the conductor, these requirements. Now this, we didn't change the intent here, but what we did was we made it read right. It never read correctly. And this was a part of my ampacity task group that I chaired. When we read through this, we said, we didn't want to change the intent, but we did have to make it read better so that we make it aware that when you do the branch circuit conductors, they have to have an ampacity not less than the larger of the two conductors that you determine. So you determine the conductor size based upon the continuous loads and the 120 working in the 125%, but not working in the conditions of use and the correction factors. You just do the 125% based upon the continuous loads, and you do that in accordance with 310.15b. And then the second way is that you calculate it without the 125%, but you do the calculation based just on the adjustment and correction factors based upon the conditions of use in accordance with 310.15b, and then you pick the larger of the two. So we didn't change the intent, but now it reads right, which it always bugged me because as I read it before, it seemed confusing, and it was because the language just was not 100% accurate. We fixed that there in 210. We did the same fix in 215. We did both of those. Basically, this is just telling you the exact same thing that I just regurgitated to you, or reiterated to you. So you pick the larger of those two, and that is the minimum ampacity and conductor size. And then you pick your overcurrent protective device based upon that conductor. So that was the change that we made in 210.9, and we did the same thing in 210.19. Actually, this was, I'll just go straight to the picture and we'll end on this one. This is permitting the sizing and use of this conductor at its 90° C rating and at 100% when you land it on these two enclosures with properly rated terminals and lugs. I would argue that the National Electrical Code did not include this, did not need to include this, because you could have done this under the current rules. This just raised the awareness that it can be done, and I would argue that this length of this conductor would have to be pretty doggone long to justify two large enclosures on the outside of these panel boards. That would have to be pretty doggone long. But anyway, I'll let that one sink in. And in the meantime, it is 2:01, and I am 1 minute past my deadline. I got through, I believe, everything I wanted to get through. I believe I got through everything. And I am going to display now the final quiz in. And thanks for tuning in. Thanks for a great session, great YouTube chats, great WebEx chats. I will, hopefully you've got the code for the PDHs. Thanks for dialing in. Thanks for hanging in there up until 2:19. And for those of you who are on YouTube, I'm going to play the outro. So again, thank you very much. And we will probably see you hopefully tomorrow for Fusology. Take care, God bless, and stay safe and stay healthy.